Alex, yeah. Number 33. So number 33 on 9.6, it gives you find the pair of numbers whose sum is 40 and whose product is a maximum. Find a pair of numbers whose sum is 40 and whose product is a maximum. You're trying to find two numbers. At the beginning of this question, do you know what they are? No. So what do you have to do with any word problem? What should you do? Define your variable. So x is going to be one number. And what's your other variable going to be? Does it matter? Yeah, so just use y. Y is going to be other number.
What's a maximum?
Well, a maximum means the maximum, the largest one. I mean, I don't know how to say it otherwise. The maximum is the biggest it could possibly be. We don't know that. We have to prove that. So that's the whole point of this. So for 33, find a pair of numbers whose sum is 40. How do you write whose sum is 40? How do you write that? X plus y. So we know that x plus y is equal to what? 40. And whose product is a maximum. So the product of two numbers is what? Multiplication. So you want to maximize what? X times y. So that right there is what we're trying to maximize. Now here's the thing. We generally don't like having two variables. We like having one variable, correct? We like having like y equals. Right now we have the maximum equals x times y. We're trying to find the maximum of that. So here's the basic idea, everybody. You were asking, like, what is a maximum? Yes, you can do these things in your head, but it's not a proof doing that in your head. You have to be able to show. And here's the idea. What type of graphs are we looking at? Parabolas. They either go up like that or they go concave down like that. Which one, down or up, has a maximum? No. This goes up forever. This does not have a maximum. Yes, exactly. This has a maximum. So that point is the maximum. What's the other name for that point? Ah, the vertex. So all this is asking you to do is find the vertex of a parabola, but we need to find that parabola first. Right now we have m equals x times a, but we want it to be in one variable. We would like it to be the maximum equals just in terms of x. If we wanted to write it just in terms of x, what do we need to get out of there? The y. Do we have a way of doing that? Yeah, what equation have we not used yet?
The top one.
Yes. Summer, can you tell me what y equals right there in the red box? What does y equal?
1/2 of 40.
Nope.
9.
What does it equal, Mar?
40 minus x.
40 minus x. So what do you do with that 40 minus x, Mar?
Plug it into the
Yeah, we plug it in right there, and what do we get? The maximum equals x times 40 minus x. Can we multiply x times 40 minus x? Yeah. So what do we get for maximum? M equals 40x minus. Is that a quadratic?
Yeah.
Is that a quadratic right there?
If you subtract the
Is that an x squared? Is there an x squared in it?
Yeah.
Yeah. Is that a quadratic?
Yeah.
Is that written in standard form?
No.
No. What should we put first? Yeah. So m is equal to negative x squared plus 40x. Correct. Now we're trying to find the vertex. If we want to find the vertex, what was the x coordinate of the vertex? Negative b over 2a. What's the a value here? Negative 1. What's the b value? 40. So if we want to find the vertex of this parabola, does this parabola face up or down? How do you know it faces down, Liv? Because of the negative in front of the x squared. Exactly. Faces down. So we want the x value of that point. So this parabola looks like this. But what's this x value? Negative b over 2a. So let's find it. So x is going to be negative b. So it's negative what? Negative what?
80.
No. What is the b value? Negative 40 over 2 times negative 1. So that's going to be negative 40 over negative 2 is what? Is 20. So we found x. We just proved that the x value is 20, but we need both numbers. How do you find the other number? Yeah, you know that x plus y is equal to 40, right? So 20 plus y is equal to 40. So what does y equal? 20. So yes, your feeling was correct, Hannah. Your feeling was correct that it was 20 and 20. But if you want to prove this, you have to find the equation and find the maximum by finding the vertex. So the way you find the vertex is you find the x-coordinate, and then once you have the x-coordinate, where do you plug it in? You plug it into the equation if you wanted to. We had a different equation we could use, but the two numbers are going to be 20 and 20. An equation. y equals ax squared plus bx plus c. On that quadratic, the vertex has a certain coordinate, right? Agreed? That coordinate, the x coordinate, is negative b over 2a. It's always negative b over 2a. And then once you get negative b over 2a, you can plug it into the function to get the y value. If you've written it, it has to be in what form?
Standard.
It has to be in standard form. If it's not in standard form, does the negative b over 2a work? No. I could prove where that comes from. It comes from completing the square.
Yeah.
But we don't need. Do you have to complete the square every time you use it? No. So for example, literally just say what is a, b, and c. I love that. Yeah, a is 1, b is 2, and c is negative 5. You don't really need it, but again, you can put it down. That's fine. B is 4. Sorry. Thank you. So then we've stated a, b, and c. So what do we find next? Which is what? The x value of the vertex. So we now need to find the x value of the vertex by using x equals negative b over 2a. So what's that going to be? Negative
4
over 2 times 1, which is going to be negative 2. So we know that that's the x value of the vertex. What do you do with that x value now? Plug it back in. You do f of negative 2. So that's going to be negative 2 squared plus 4 times negative 2 minus 5. That's going to be what? Minus 8 minus 5 is negative what? So what's the vertex? Correct. Negative 2, negative 9. Exactly. Very good. Now again, kids, parabolas can go up or down, right? If it's going up, the vertex is the lowest point. If it's going down, the vertex is the highest point. Can a parabola have both a max value? So what's the x value you're looking for? Negative 3 over 2 times negative 2. Yep. So it's going to be what? 3/4. So again, this one's a little nastier because then you have to take this and do what with it? Plug it back in. So it's just fraction. So it's g of 3/4 negative 2 times 3/4 squared plus 3 times minus 1. So yeah, it's just a little bit of fraction work. What's 3/4 squared? 16ths plus 9 over 4 minus 1. So what do you have here? Negative 18 over plus 9 over 4 minus 1. How should I go about adding those fractions together?
Wait, you dropped the 2. Wait.
I multiplied it. So what should I do? Someone give me a verb or a sentence. What should I do? Multiply what by what where? Multiply what by a common denominator? So multiply what by what?
9 over 4 by 4 by 4. No. 9 over 4 multiplied by 4.
How about we multiply everything by 16?
You can do that too.
Can we do that?
Oh,
How about we just multiply everything here by 16? You could do that. Is there a fraction there we could simplify first?
Yeah. 16.
Negative 9 over 8 plus 9 over 4 minus 1. And now what could I multiply everything by?
8.
Multiply by 8. Just nice. So if you do that, what do you end up with?
Negative 9.
Plus.
18.
Nope. Oh yeah, 18. You're absolutely right. Sorry. 9. The 4 and 8 becomes 2. 2 times 9 is?
18.
Minus what?
8.
Oh, that's pretty nice. So what do you get? What do you get? Aubrey, what do you get?
Wait, can you just...
3 times 3/4 is 9 over 4. It's there, right there. This right here is there. 3 times 3 is 9, 9 over 4. Does this factor?
Yeah.
Come on. Yes, it does. Have some confidence. It does factor. What does it factor into?
Oh, yeah.
X what? Plus 3? Does that work? I think it does,
Yeah,
right? So therefore, x minus 4 is 0, or what? X plus 3 is 0. So x equals 4, or x equals what? Negative 3. So if we were to take these numbers and put them on a number line, so let's say I had a number line. Remember the number lines? They made you feel all nice and fun, right? Where are those two numbers? We have what? Negative 3 and what? 4. So the function at these 2 points equals 0. Do you agree? So this is the x value, and this is what the function equals. Agreed it equals 0? Does it equal 0 anywhere else? No. You just did this math, and does it equal 0 anywhere else? No, it does not. So everywhere else, if it's not equal to 0, it has to be positive or it has to be negative. A number is either positive, negative, or what?
Imaginary.
No, zero. A number is either oh, actually, that's a valid answer because no, imaginary numbers can be positive or negative, so that's a good guess. But real numbers, we're still on the real number line here, either positive, negative, or zero. The first thing I want to tell you, I want to ask you this. So let's say a function was positive here and negative here. What can you tell me has to happen between those 2 points? If I were to connect those 2 dots with a continuous line, what does that green line have to do? It has to go through the purple. Do you agree? The only if this goes infinitely left and right, if I were to connect these 2 points with if I could go in any direction, they would have to cross this, right? But here's the thing: we know that the only places 0 is hit. Where's the only place 0? Where are the only 2 places where 0 is attained? Here and here. So is it possible to have 2 points like this?
No.
No, because if 2 points could be like this, somewhere here it would have to cross. What I'm getting at is, once you find the zeros, what can you tell me about all the function values right here? They either all have to be positive or all have to be. Does that kind of make sense to you? All positive or negative. Because if it alternated, what would have to happen in between? There would have to be another 0. Like, can I get from here to you without going across that line right there? No. The only way I can do it is to jump over it. But do our functions jump? Our functions are continuous, right? They can't break yet. It's called continuous functions. They're all continuous. So what can you tell me about all these values? They have to be all positive or negative.
Don't those only have
Wait,
to be negative?
nope, we don't know yet. We don't know yet. We haven't figured it out yet. All positive or negative. And this one right here, all of these have to be all what?
Where?
Sorry, the yellow over on the right. So all positive or negative, all positive or negative, or all positive or negative. What I'm trying to tell you is the sign of the function could only possibly change here or here. Could it be positive and 0? So it could, yes, absolutely. But if, for example, let's say we plugged in one number and this was negative over here, what does it mean for all of these numbers? They're all negative. Let's say I plugged in an x value here and it came out to be 17. All of these have to be positive. And if I plug in one number over here, whatever sign it is, all of the numbers have to be that sign. This is going to be really important because I'm going to ask you, let's say I did the same exact thing. So let's say I took this right here, but instead of setting it equal to 0, I asked you this and pasted it in the wrong place. Wow, it is being a little cranky today. Let's say instead of this, all I did was change one thing. Let's say I changed it to, where is it greater than 0? So what do you think the first thing we're going to do is? We already did the first step. No, what did we do on this one? We solved for when it equals 0. So what do you think we're going to do here first? Solve. Oh, did we already do that work? Yeah, we know that this equals 0 when x is what? Negative 3 or what?
Did you just find your no base?
Hold on. No. Just please go with this and just follow this story for now. So I set you up. We already did that work. So, but does that tell us where it's greater than 0 yet? Not yet. But we know it's 0 here. We know it's 0 right there and right there. Right? So what do you do next? What do you think you do next, Alex? Exactly. You plug in a number for each of the 3 regions. There are 3 regions. Remember the 3 regions? The green one, the yellow one, and the blue one up there? Can you pick any number you want in that region? Sure. So the function we're looking at is right here. See that function right there? X squared minus x minus 12. What's a great number between negative 3 and 4? Always try to use 0 if you can, because how easy is it to plug in 0 into things? So if this right here is f of x, can you tell me what f of 0 is? 0 minus 12 is? It's negative 12. So what can you tell me from here, the middle part right here? All negative. Do you agree? So there are 2 other regions. What number do you want to plug in next?
Negative 2.
No, you can't plug in negative 2. Negative 2 is in the region. Sure, we can do negative 4. Sure. Or negative 5 or negative 6 or negative 7 or negative 8. Doesn't matter which number we choose as long as it's to the left of negative 3. Or we're going to have to do both, right? Because we need to check all of the regions. So let's check to the left of negative 3 first. So what was that number you wanted to check? Negative what? So f of negative 4. That's going to be negative 4 squared minus negative 4 minus 12. What's negative 4 squared? So 16 plus 4 minus 12, it's going to be what? 8. So what can you tell me about this blue region right here? It's all what? All positive. So then what number do you want to test next?
5.
Yeah, 5. Could you theoretically test a billion if you wanted to? Why don't we choose a billion? Choose numbers that are easy. Like between -3 and 4, could we have chosen like 0.25896? Sure. But what's a better number to test?
0.
Why? Take the easy. F of 5 is 5 squared. Was it minus 5 minus 12? 25 minus 5 minus 12. So what's that going to be? It's going to be 8 again. Right? It's going to be 8. So what do we now know about this yellow region right here? All positive. So what does this tell us? If this question is asking where is this function greater than 0, could someone verbally describe for me where this function is greater than 0? Alex, where is it greater than 0?
It's greater than 0
when
x is less than -3
Yep.
or greater than 4.
Or x is greater than 4. That is perfect. That is 100% the correct answer right there. When x is less than -3 or when x is greater than 4. What happens when it's equal to -3?
0.
It's 0. Is that what we're looking for? No. What happens when it's equal to 4?
0.
It's 0, but it's not what we're looking for. Okay, everybody can sit down now. Sit. If I said, hey, so just remember, you need to write it like that. That's great. When x is less than -3 or x is greater than 4. That is fantastic. What does this look like visually? What does this look like visually? Well, if I graph this function, I'll show you what it looks like. It looks like this. We know it crossed at what? -3 and 4? This is not to scale. You got it? -3 and 4. What does this function look like? It goes down like this. Where is it? So we know that this is 4 and this is -3. Where is this thing greater than 0? It's greater than 0 starting there and right there. But what are the x values for that part of the function? What are the x values? Greater than 4 or less than -3. If I asked you where is that function less than, where is this function? If this is f of x, where is f of x less than 0?
Greater than -3, less than 4.
Yeah, greater than -3 and less than 4. Remember the inequalities like that? Function is either 0, positive, or negative. There's only 3 choices. Okay, so what do you think you do first? Sure, -1, but it's an inequality. What should you really be looking at first? No, it's fine. What did I tell you? What did we do first up here? Set it equal to what?
0.
No, set it equal to? You can either, inequalities, I will say, you can if you want to add or subtract the same thing from both sides, but just set it equal to 1. Solve this first. So now what do I multiply both sides by, Nick?
Pretty much did everything.
Okay, so lead me through it then. What do I multiply both sides by, Nick? So -1 is equal to x minus 3. What do I add to both sides?
1.
No, add 3. So x equals what? 2. X is equal to 2. So this equals 1 when x is equal to what? 2. So what can we do with that information? We know that it equals 1 at 2, right? But we're looking for when it's greater than 1, or we want to know when it's greater than 1, correct? So we can either do it this way, or some of you, can you subtract 1 from both sides if you wanted to? Could you do that to start with?
Yeah.
Is it legal? What I'm saying is it legal? Instead of doing this, is it legal to do this instead? Could I instead say -1 x minus 3 minus 1 is greater than 0? Could I do that instead? Sure. Absolutely could do the same thing. Is this going to change our final answer at all? No. If what we've done is mathematically legal, does it matter when we do it? No, not really. So if we want to solve this, what was our first step before? Oh, it's still an inequality. We don't like an inequality, so what do? Yeah, set it equal. I like how you said that. Hey, are we back to where we started with in the first place? The reason we like to do this, let me just tell you why this is really key. It doesn't really change the overall difficulty level, but is it really nice to have a 0 over here? Yeah, it is. Because by having a 0 over here, we're going to look to find where it's positive and negative. That kind of thing. It's much easier to have a 0 here. Is it going to change the math at all? Not really. Because what can we add to both sides now if we wanted to?
1.
We could add 1. So what I'm telling you, a great place to start is just make it greater than 0 first and then do the algebra. Is it going to change the overall work?
No.
Is it going to change the overall work, Nick? No. It is not going to change the overall work. So if we do this, what do we end up with? Oh, the same thing. Did we just do something like this? So negative 1 is equal to x minus 3. So what does x equal? 2. So we know that this thing is true. This is true, meaning negative 1 over x minus 3 is equal to 1 when what? When x is equal to what? And it kind of makes sense because when you plug in 2 into this, what's 2 minus 3? What's negative 1 over negative 1? 1. So this is equal, but are we looking for where it's equal? Are there any other points? Are there any other x values that make it equal to 1? No, it's the only one. So all the other ones have to be either greater than 1 or less than 1. So make that little line right here. What do we get? We have x is equal to 2 right there.
Yeah.
So all of these values have to be greater than or less than 1, and all of these values have to be greater than or less than 1. So what do you do once you have your two regions? Pick a number. So what's a number less than 2? That's really easy. 0. So plug 0 into here, Mar. Plug 0 in right here. What's negative 1 over negative 3?
1/3.
Is 1/3 greater than 1? No, it's not. It's not. 1/3 is not greater than 1. So we know that this one right here is, on this side, this is less than 1. What's a number to the right of 2?
3.
Oh, okay. Can we plug in 3 here?
No.
So we're going to have to come back to this idea in 1 second. Be very careful. Can you plug in 3 into this? Why not, Jen?
Because you can't have 0 and then
Okay, so we're going to put a pin in that for a second. Just keep that in your mind for a second. So let's not choose 3. Let's choose a different number. How about a bigger number? 4. Let's plug in 4. What's negative 1 over 4 minus 3? Negative 1 over 1 is negative 1. Negative 1 is less than 1. Oh, okay, hold on. So what do we think? When we plugged in 4, what did we get? Less than 1. When we plugged in 4, we got less than 1. So we're not done yet, because remember that pin we stuck in? There was a problem we ran into, which is a great problem to have. I'll explain it in a second. Based on this information, where does it look like this fraction is greater than 1? Nowhere. It looks like it's greater than 1 nowhere. Because we chose a number less than 2 and it was less than 1. And we chose a number greater than it and it was less than 1. But here's the thing. Mar, remember when I was standing here and I said, if I want to walk to you, and I can't, I have to go past this, I have to go through this line, right? Because I can't jump, right? Remember I said these functions can't jump? This function right here, is this a quadratic? No. Is this a line? Is this a linear function? No. This function right here is bendy, and it has something in it called a discontinuity, meaning, can this function jump?
Yeah.
It can, because it has something, they don't use the name yet. This has an asymptote. It has a curve, but here's the thing. You know it has one of these things because can you plug in 0? Sorry, can you plug in 3?
No.
Can you plug in 3?
No.
Because if you plug in 3, what happens to the denominator? It becomes 0. So what's the domain? Can someone tell me? What's the domain of this function? X such that x cannot equal 3. Do you remember this domain set notation? So remember how we made this region right here? Why did we choose 2? We chose 2 because it made it equal, right? We also put in the values that can't be in the domain. Because when those numbers 3, that number 3, can you plug 3 in? No. You can plug in everything else. What's really interesting, at those points like where x equals 3, it can instantaneously change from positive to negative. So how many regions? You have a green region and you have a purple region. There's actually another region to put it in. What was that value? What was the value that we can't plug in? 3. So what you do is you put a little dot here where x is equal to 3, and there's actually a third region in there. What's the third region?
Between 2 and 3.
It's these two right here. So we know definitely that from here to here, it's less than 1. From 3 onward, it's less than 1. But we need to check this right here, between 2 and 3. So unfortunately, what are we going to have to use? A fraction. I know you get kind of sad, right? But luckily, is this function super complicated? Not really. What are we looking at? We're looking at negative 1 over x minus 3. What number is nicely between 2 and 3? 2.5. What's that in fraction form, Mar? 2.5 is not 3 over 2. In fraction form, what is that? 5 over 2. It's 5 over 2. So if we do this, what is negative 1 over 5 over 2 minus 3? How many halves are there in 3?
6.
So it's 6 over what? 2. So that's negative 1 over, negative a half, right? Because it's 5 minus 6 is negative 1. Yeah. We're saying the answer. What's negative 1 over negative a half? What's negative 1 over negative a half? 2. It's 2. Hey, is that greater than 1? That is greater than 1. So what do we find out about this yellow region right here? Greater than. So what's the answer to this question? Where is this greater than 1? Between greater than 2 and less than 3. So you see this colored bar, right? You see this colored region? This is what you're working on making right here. You're working on finding, why did we choose 2? Because it made the equation equal. And why did we choose 3 right here? Because that's where it makes the function not defined. We couldn't plug in 3. So you put 2 in, you put 3 in. And then how many colored regions do we have? 1, 2, and 3. You have to test all 3 of them. You test all 3 of them. Milo, yes?
For our answer, when we do this,
yes.
Do we make a number line and do that?
You make a number line, but final answer, say it like this. Just, I like that. Remember, there's also, you could write it like this. 2, 3. That's interval notation. Do you remember that? You could also, why do you guys not really like that too much? Well, what is it? Yeah, hard brackets mean it contains it, but what does interval notation really look like? It looks like a point, right? So some of you write interval notation, you just got to be careful. I like writing, this is interval notation. But I really like this, because is this clear right here? I think it's clear, and that it's like making arrows like this. Can you just really quickly, what's one of the numbers that we have to put on this number line as a boundary? Why negative 2, Liv? It's not in the domain, right? When you plug in negative, can you plug in negative 2? No, you can't. So what you do is you then say, okay, negative 2 is going to go right here. But what else do you have to do? You have to solve. What do you have to solve? Equals to 2. What do you multiply both sides by, Nick? Right here. What do you multiply both sides by right there? X plus 2. So what do you get? X minus 2 is equal to 2 times x plus 2. X minus 2 is equal to 2x plus what? 4. Like that. So then you subtract 4 from both sides. You subtract x from both sides. And what do you end up with? Negative 6 is equal to x. So you plug the negative 6 up here. How many regions do we have? 1 region, 2 regions, and blue. And you test all 3. Okay, your homework is in 9.17.